Hello everyone. Today I am excited to present a project I have recently completed. And name of the project is Creating a Secure Network. Let me start by giving you a quick overview. I was hired as an IT expert to make a company's computer system more secure without adding new hardware. My solution was to use a virtual environment called VirtualBox, which allowed us to run all necessary applications without taking up more physical space. Here are the key tasks I completed in this project. Installed VirtualBox on a Windows system. Added all necessary virtual machines to VirtualBox. Fixed a network error on the CEO's virtual machine, allowing access to a crucial website. Downloaded the client's social media network policy document to the CEO's computer. Used Wireshark to capture the file transfer process from the web server to the CEO's computer. Documented the IP addresses and operating system versions of the CEO's computer, web server, and DNS servers. Created a new user account on the web server. Used Nmap to identify open ports on the servers. Verified the security of the trusted network against the untrusted network. Here's the network diagram I used for this project. As you see on my left, we have the trusted network, which includes the CEO's PC and a Kali Linux system. On my right, we have the untrusted network, which also includes a Kali Linux system. At the bottom, we have the DMZ network, which houses the DNS server, web server, and another Kali Linux system. All these networks are connected through a router firewall, ensuring secure and managed communication between them. This setup allows us to efficiently manage and secure the network by segmenting trusted, untrusted, and DMZ networks. I downloaded and installed the virtual machines in VirtualBox and configured the required network setup. Here's how it looks. One of the main challenges was accessing the website www.seclab.net from the CEO's computer. I resolved this by switching the network IPv4 setting method to automatic DHCP and adding the DNS server IP address. I also documented the system details for future reference. Here are the specifics. Here are the system details for the CEO's PC. I ran the following commands to gather the necessary information. ifconfig eth2. Details obtained: system IP address, broadcast address, and subnet mask address. Next command: cat/etc/resolve.conf. Details obtained: name server IP address. Next command: netstat-rm. Details obtained: default gateway address. Next command: cat/etc/CentOS-release. Details obtained: CentOS version. Next, system information for web server. Here are the system details for the web server. Command lsb_release-a. Details obtained: OS version 8.04. Next command: ifconfig eth0. Details obtained: system IP address, broadcast address, and subnet mask address. Next command: cat/etc/resolve.conf. Details obtained: name server IP address. We can use similar commands to retrieve the system information for the DNS server. Here is the system information for the DNS server. Next, file transfer process using FTP. To secure a critical policy document, I utilized FTP to retrieve the social media security policy from the web server and securely transferred it to the CEO's PC. During this process, I employed Wireshark to meticulously capture and analyze the file transfer traffic. This ensured that the data was transferred securely and without any integrity issues. Next, user account creation on the web server. To enhance security on the web server, I created a new user account specifically for managing sensitive operations. This new account has restricted permissions, allowing only essential actions to minimize potential security risks. By implementing this new user account, we can better control access to critical data and reduce the risk of unauthorized activities on the server. This step is part of our ongoing efforts to strengthen the overall security framework of our IT infrastructure. Next, port scans and security verification. Using Nmap on Kali Linux, I performed port scans on the DNS and web servers to ensure there were no vulnerabilities. This helped verify the security of the trusted network against the untrusted network. Security recommendations and closing remarks. To conclude, it is advised to pursue the following strategies for future developments. Expanding the new virtual network is now achievable, allowing for increased functionality without the necessity for additional physical space or hardware. Considering leasing or outsourcing hardware may be a viable option to minimize initial expenses and maintenance efforts. A thorough examination of the existing physical network should be conducted to pinpoint and eliminate obsolete hardware. This will not only liberate space but also lead to cost savings. Thank you for your attention.